Hello, everyone. Welcome to the Java Bootcamp. This is the third session of the Java Go Camp. And I'm very, very excited and happy for this session. I've been having a great time coding along with all of you. Let me introduce myself for those of you that are joining us today. My name is Mati. I am a software engineer, a subject matter expert here at Globant, and I'm based in the UK. And we have been coding along during the last 2 weeks, learning about functional programming, coding live together. And so this is the third session in which we are going to be learning more about functional programming patterns. Last week, we had a great time learning about different functional programming patterns like funter, monoid, um, MapReduce, monads. And today we're going to be looking at some of the patterns that are built in with Java since version 8. Some of them you might have heard of, or you might even have used them in some capacity, like Stream API or Completable Future or Optional. And finally, we will also be implementing our own pattern, so I hope you are as excited as I am. So everyone, welcome. I am going to send the code for today's session so that you can also pull that code from GitHub, and you can follow along the lesson. And then, as always, feel free to ask any questions during the comments, and I will take sometimes where I will take the questions and I will try to answer the questions. And just feel free to say hi. Feel free to chat and give me suggestions while we're coding. We're doing this together, so yeah, this is a great it's going to be a great opportunity for all of us to share together. And all right, so we can start with our presentation now. And I'm going to start talking about the Stream API. So we briefly touched on the Stream API because we have been working together and we have been implementing a lot of features together, and we have used the Stream API. And this API is basically it's a data structure that represents a sequence of elements. Some people call it a glorified iterator. So basically, an iterator that is so nice to use, which in some sense it's true. So it's been available since Java 8, and we are currently in the 19th release of Java. So it's been a while since the Stream API has been going on there, but since then it has been like the Java the Oracle team that develops Java have added a lot of features on top of the Stream API. So it's been growing, it's been becoming even more powerful than before. Um, and as I told you before, these streams are a sequence of elements that you can process. And these streams are also something that is disposable. They're not supposed to last for a long time. And so that's one of the main difference between a stream and a list or a set or a collection. Basically, a stream is something that you want to use very quickly and get rid of, and it's not something that you want to keep forever, or you don't want to keep it in memory. And there are many reasons why. Like, for example, once a stream is consumed, it cannot be consumed again. So if you are using a stream, if you consume the elements of that stream, you can either create a new stream with it, or you can consume them, process them, and that's it. You won't be able to operate with that stream again. So that's why we mean that stream elements can only be consumed or visited once. So as I say here, if you need more than one visit, to any of the elements of the stream, you need to create a new stream with those elements. Then there are many operations that stream have, like map, which is the basic functor pattern. We have filter, we have any match, we have find first. Some of them we have used already, and they used to operate with the stream and with the elements. Some of the operations transform the elements, like the map operation, and some of the other operations, like filter, they don't transform the elements, but they transform the stream itself. Some elements are removed from the stream. So that's why some operations transform the stream, some operations transform the elements, and some operations just consume the stream. Like for example, any match or find first. Those operations will completely eliminate the stream and just keep one value, for example, or they will produce one value. Um, and then there are streams that can be infinite. Like you could have a stream that can be creating new elements forever. And there are some operations that you can use so that that generation stops. And those operations are called short circuiting operations. So we move on a little bit more. We have um, different types of operations with streams. These streams, for example, we have intermediary operations, and these operations are basically things that transform the elements or visit the elements of the string or transform the stream itself, but they don't complete the use of the stream. For example, map, filter, distinct, sorted. These are all operations that will transform the stream or its elements, but they will not end the execution of the stream. So, for example, I can chain multiple map operations, or I can mix filter and then map and then distinct. So, basically, these are operations that are in the middle of the flow. Some of these operations are stateless, and some of the operations are stateful. What do we mean by that? Like, stateless operations are operations that in which you don't need to know what happened with the rest of the elements of the stream. For example, if you do map, the map function is a stateless function. So if you run the map operation on a stream, you don't depend on the rest of the elements to do a mapping. So it's considered a stateless operation. And that gives you a lot of advantages because you can parallelize that execution. And then there are some other operations like sorted, for example, which are considered stateful. And that the reason why is because in order to sort a sequence or to sort the elements of the stream, you need to know about the rest of the elements so that you can put them in order. And that's the reason why it's considered stateful, and that's why you cannot run that in parallel. And uh, and there is one important thing about intermediary operations. This will never be executed until there is a call to a terminal operation, which is the second type of operation that we have. Terminal operations are the ones that we use to produce a value or a side effect. So you will only execute one terminal operation, and that's it. Yeah, you have to get rid of your stream. So, for example, one terminal operation is for each. For each will do something for each element of the stream. And once it's executed, the stream will be disposed. That stream cannot be reused. Um, Other example is, for example, reduce, which we use as well last in our code camp. And we why did we use reduce? If you remember, we use reduce to do a sum of all the distances of a path. Remember that? So we can reduce. It's a terminal operation because it's something that once you do that, you cannot do anything else with that stream. And it's really important that we understand the differences between these two kinds of operations when we deal with streams, because if you if you don't call ever a terminal operation, this will not uh, this will not take any effect. Like, let's say you want to transform elements of a list, right? So you create a stream and then you do map. If you don't call a terminal operation on that stream, that map will never take effect. It will never even be called. Like the inside function, like the function that you passed on the map operation, it will never be called. And that is really important, because there are other languages in which if you call map on a list, it will automatically transform that list. But in this case, in Java, we have this differentiation between intermediary and terminal. So let me give you an example. Let's go to our code, and we have our function path list in the path list class. Remember the path list class. We have a function called the shortest path. So you see, in here we're using a stream of paths, and we're filtering the paths using a condition, right? So this filter, um, it's something that will never be executed until I execute a terminal operation, like I'm doing here. So mean, this is a terminal operation. And how do you know which one is a terminal, which one is not a terminal? I mean, you can try and deduce that. You can try and say, okay, this sounds like a terminal operation, like for each, or min, or find first, because it looks like it will give you a value, and that is a good thing to do. I mean, you will gain that intuition, but there is an easier way to check this, which is basically you read the documentation here, and it will say this is a terminal operation. So it's really well documented. So if you want to understand what kind of operation you're dealing with, you just need to read the Java doc here, and it will tell you. For example, in filter, if I go here, and it will tell me immediately this is an intermediate operation. You see, and it will not only tell you that; it will also tell you that it is a stateless in this case. Why? Because this doesn't need to know about the rest of the elements to apply the condition to filter. So we have other examples in our previous code. Let's take a look. We had in the path class. So we have a stream of segments here, right? And this stream of segments, we apply the map function. So if we apply the map function here, but we don't apply the reduce function, let's say I remove this, of course I will not have a big decimal to return. This will return something called, if I put this into a variable, it will return a big decimal, a stream of big decimals, right? So but this is not even executed. And to do this, I'm going to create quickly a main class to show you what happens. I'm going to say, for example, stream example main. right? And let's create some paths. Or what was the class we were looking at? Yeah, path. So I'm going to create a path from our test, like we did here. Um, no, actually, not a path. I'm going to let's just use strings, right? So I'm going to create a stream. I'm going to use stream of, and this is a different way in which you can create streams. You can say stream of and just pass some strings, like for example, Mary, Paul, Peter. If I put this into a variable, this is a stream of strings. Okay, and if I do stream the map and I just transform these strings in, let's say I put them all in uppercase. So I'll do S to uppercase, right? I can put this in method reference, right? And if I, for example, actually, instead of just doing this, I'm going to create a full body lambda, and I need to put this like that, and I'm going to put a console message here, uh, running map operation, right? This is for debugging purposes. We don't do this, right? But in for our debugging, I'm going to do this. So what are we expecting here? What I am expecting is that nothing will be printed, and the reason why is because um, this will not be executed because it's not a terminal operation. And if I run this, I'm running it right now. You see, nothing was printed, nothing. And the reason why is because this is a terminal operation. This is an intermediate operation. It's not a terminal. So how do you run this? Well, I could do this, for example. I could do for each and simply uh, print every element of this stream that has been transformed into uppercase, right? So now I'm expecting this to run. So this will be printed 3 times. Let's just add here as well um, S. Let's say S, and we'll see the value of the string as well as we're printing. So now we're looking. The output should be 3 times this, and then the three strings all in uppercase, right? So we see running map operation and then Mary, running map operation Paul, and then running map operation Peter and Peter all caps. So this is why now the map operation was run because it has been chained with a terminal operation. Another thing that we cannot do, for example, let's say we don't run this with a terminal operation, and I just run my original stream, and I want to do the same here. System out print line, right? So I want to use this stream, and I'm going to put this into a variable so that you know these are two different streams. all caps stream. Two different streams, right? The first one, my original one with the names, and the second one with all caps. If I try to use the first one, after I transform, you see what happens? I get an exception because I can only transform the stream only once. I did a transformation with this, even though it hasn't run, because this code hasn't run. The pipeline the pipeline was structured, so this operation it has been saved to run. So the state of the stream has changed in some way. So I need to use this one and not this one. If I change it here, then it will run again. Right? So there are a lot of different operations that we can do on streams. There are different ways in which we can create streams as well. For example, one way that it's usually very useful is to create int streams. For example, when we want to build a stream that it's from a particular size. For example, you can use like a range, so 0 to 10, and it doesn't include the ending, and it's very used when you have a list. So if you have a list, you can say size. So this would be very useful to go around a list. So this will create something called an int stream. And this int stream has a lot of different operations that are prepared for integers. For example, uh, you can do average, um, you can do sum, because it's already prepared for the int type, and you can map one int to another int, or you can map it to an object, and that will give you a stream of objects. So for example, you can map it to strings. If I say I and then I say integer value, no, not value of, string value of I, and I can use method reference. And I had to remove this. So you see, we have printed everything, but these are strings. These are not ints, because we turned them into strings. So int stream is really useful for that. Then we also have stream generate, and this takes a function, a supplier function, and this could be anything, and this could generate uh, values forever. So you can put here a random sequence of generation or whatever you want. So how do you stop this from generating values? You can basically say, for example, take not take limit 10, and this will only get the first 10, and that's it. And then there is take while, and this takes a condition. So it will generate values until you reach a condition, and then it will stop generating values. And this will return an stream as well. So these are very useful ways to create streams. Are there any questions? Let's see. Is there any way to check if the stream was not consumed? Um, Actually, I never thought of it. Um, but it's usually really hard for you not to notice that it's being consumed or not, because you should, like, the way the API is designed is that you should use the stream and dispose of it immediately as soon as possible. So you can return a stream as and you can pass the streams as parameters, but that could lead you to these kind of issues where you don't know if the stream was consumed or not. So you have to be very careful. It's usually better if you use the stream inside one method. You create it and dispose of it in one method. That's the best way. But you can also send it as a parameter. Um, I haven't thought of any way. Let's see if we have something here. Um, I don't see anything like that would give you something about the state of the stream. I guess, yeah. I guess there is no way to see if it's being consumed or not. But we'll need to check more. Let's see what else. So we have talked about terminal operations and intermediary operations. So let's let's just go back to our stream with the names, and let's just keep working with that one. Um, okay. So now that we have out this stream, what other things we can do with the stream? For example, because the stream it implements the monad pattern, we have the FlatMap method, and we have spoken about the FlatMap method before. This method here will basically take transform elements of the stream into streams, and it will put all the streams into a single layer of stream. So, for example, I could say I could transform a string into a stream of characters, right? So, for example, I have this, and I could say uh, chars. You see, chars, it returns an int stream. So I could basically say map to object, and again turn this into a string, and say, for example, um, char. I could set like this. Now I think I need to just say like this. So now this returns an int. So this will return a stream of characters. You see? So each word here would be a stream. So if I do map here, you see what happens? I have a stream of streams of characters. But if I do flat map, I have only one layer. And I can print all this, for example. Let's say system out and line. And let's remove this, so we don't need it. Run this. You see, now I have all the characters in a single list, basically. I could instead of introducing a side effect, because for each is used to introduce side effects, something that it will change the state of the application. In this case, it changes the status of the output. But it could basically also say to list, and this will return a list of characters, right? And then I could also, uh, just for the sake of this, I'm going to leave here the for each, and I'm going to say, um, I could basically say now map and turn every character to upper string, to uppercase. You see? And now if I print this, everything should be uppercase. And here we are. And I can do all sorts of things. I could filter. So let's say I don't want the letter A for some reason. I could say S e- equals the letter A. And if I run this, you see now I don't have the letter A in my list. I could you also do find first, which will return the first value of the stream, if there are any, because the stream could be empty. Or I could do find any, which will return any value. And in most cases, it will still be the first one. But there are some streams. If I can, for example, I could do parallel. And this will turn my stream into a parallel stream. So this will execute the pipeline in parallel, and this doesn't guarantee the order in which it's going to be processed. So if I do find any, uh, this doesn't guarantee. So it's going to take the first one that was processed, but we don't know which one that would be. So that's the difference between find any or find first. Then we could also do something like any match to produce values, and any match receives a predicate, right? So I could say, are there any m's, for example, and this will return true or false. That's it. And this is really useful. We also have min, and we have to send in a comparator. We also have max, to get the max value also with a comparator. Um, we have count. We can count the elements of the stream. Um, and then one of the most useful operations here as well is there is a pick operation that will help you debug your stream. So, for example, I could say s, and I want to pick what is the value of it. So I say system out, and sorry, not this. Print line. The value of s is, and something like this. So this is really useful when you want to debug and add some debug message to see what transformation has gone on, has been happening. And it's an intermediary operation, and you have to be very careful when you use this pick operation, because you should not change anything when you do this. Like, you shouldn't do something like, for example, s dot to uppercase. This, in this case, it will do nothing. But if you don't have an immutable class like string, if you have your own class and it's not immutable, and you somehow change the internal state of your object, then you have introduced a side effect into your code. So you extremely careful when you use this. Only use it for reading and writing into logs or some that kind of things. Um, are there any other questions regarding streams? Um, this, it says an example for using stream. Let's say a microservice, and when is better to use it. Oh well, I use stream all the time, all the time, and you have seen this. I mean, this is not a microservice, but this could well be a microservice for getting for transforming paths and processing path lists and on that kind of things. And so basically, you can use it whenever you need to process things that are in lists that you can process in a sequence. Anything that you have it in a sequence, anything that you would write a for loop with for, you surely can do it with a stream. And the advantage of using stream is going to be that basically it's going to be more declarative. Like, for example, if we look at path, our path class, you see this is not something that we could do. Like, this is something that we could easily do with a for loop, but the for loop doesn't look as good as this, because this is more declarative. You see, we are just saying exactly what are we doing, and we don't have to handle um, helper variables and that kind of things. So you see, we have a stream here, and we're just saying transform the elements into distances, then add all the distances, and just in case there is none, just return zero. So that's really uh, useful. So I would say I use it everywhere in microservices, uh, in any kind of application, and you will it will always be good for you. Um, right. So let's take a look at the our next pattern, that is the completable future. So the completable future is a very interesting pattern. If you have been using something like JavaScript, you may have heard of something called a promise. Completable future is a very similar concept. So, for example, you have um, a single thread application, right? And you send some requests to that application to be processed. If that application has some expensive computation going on, you would need the user would need to wait for that response, and then you can, once the computation is over, you can return the control to the user. And imagine this is for example, a UI application, like a front end application, a mobile application, where if the user wants to do some operation and clicks on a button, and that button goes into an expensive computation, because the application is drawn on the main thread. If you have an expensive computation going on in the same thread, the application would be it would freeze. the screen would freeze and the user won't be able to do anything, and they would not understand what's going on. So that's why we handle things asynchronously. And there have been always a lot of different ways to handle things asynchronously. This is not the first time. Like the Completable Future is a new abstraction that was created to handle things asynchronously in a more functional way and in a more declarative way as well. Because um, it will it will you will not be dealing with threads directly, and it will be very easy for you to understand what is going on. And so we use completable futures so that we can handle these expensive computations on a different thread, and we can return control of the application to the user. Um, there are other reasons why we could do this. For example, let's say we have many computations to run. They are all expensive, but we could run them in parallel because we have many CPUs or many cores in our CPU. So what we could do is split the computation into smaller parts and run them in parallel and wait for the result to finish. So these kind of things we can also do with Completable Future. We can create many Completable Futures and then wait for all of them. And because it uses the monad pattern, you can compose Completable Futures together. And there are many ways you can do this. So basically, you can create Completable Futures to track async tasks. You can chain many operations together. This would be the functor mapper, like the map operation of Completable Futures. And then you can also compose Completable Futures together. And that would be the monad pattern. Um, you could, let's see. Yeah. Let's go to the code. And I'm going to be using this same class here to give you an example. Not this class. I'm going to be using this one. I created this class path application, and I'm going to create our path service that we created last week. Uh, and then some new service, which I call the notification service. You won't have this one, but you can create it as a class here, and you can basically add this. And I'm going to add another thing in our. So basically, the notification service is simulating being a service that will send a notification to a user. So I'm going to be printing the notification in our standard output, but you can. This is obviously a mock implementation. So if I go to my path service, I'm going to be modifying this one from the one that from last week, and I'm going to be returning the path list in this case. So return, and I'm going to remove this part here, the if present, and optional path with transport. Right. So another thing that I'll do here is I forgot to put the there semicolon, and now I'm going to add something here. Red slip. The reason I'm doing this is because I want to simulate the fact that this is going to take some time. So I'm going to write a log message here. I'm going to say finding paths. I'm going to put this inside a try catch. And then I'm going to also print path found. So this is basically simulating that this operation takes 2 seconds, which it doesn't. But I want this to take 2 seconds so that we can see what happens, and we can see how this runs into different thread. So if I go here, what I'll do is I'm going to say path service find path with transport, and I have to send. I'm going to move this. I'm going to remove all this from here, and I'm going to put it in the application. Right, and so we have a list of points. So basically I'm going to use this point. Then I have to send a path list. Do I have a path list here? I think I had it in the path service here. I'm going to move here and put it in the path application. Right, and I'm going to be using a new path list. Create path. So I have the list of points, then the path list, then the public transport, and I'm going to say new public transport list of. I have a list of public transports, and finally the transport type is going to be bus. Right, so I have this is an operation that returns an optional. So now I can map this operation. I can use map on this optional because it's a functor, and I can basically do this is a path with transport, and I'm going to say path with transport dot I'm going to say notification service notify user path with transport. I think I'm going to be able to use method reference. No, I'm not. No, because shouldn't be map. This should be if present. Yeah. Right. So now if I run this, and I'm saying here, I'm going to say here, process completed. Right. Now I run this. Whoops. I'll remove this main that I created before. Sorry. If I run this now, you see it's taking time, finding paths, and then path found, and it's writing this, and I don't see this line. Path found for user. Oh, process completed. He didn't write in a different line. Oh, because this is not new line. I'm going to put here new line just in case. Run this again, but you'll see now, say taking time, then path found, then the notification sent to the user, and then process complete. Now, if I use Completable Future for all this, say I say Completable, right, I'm going to say Completable Future, right? And there is a lot of methods in Completable Future. So how do I run this part in background? So there are different methods here, and I can use one specifically called supply async. Why do I use supply async? Because there is this interface called the supplier that it's something that doesn't take anything as parameter and returns something. We don't have any parameter to send to this operation really, because this is the main function. We don't have any parameters. We are going to basically say supply here, and we're going to send this operation. So I could put this like this. I could say no parameter. So this is a supplier. I can put this inside here, and it would be right, and it would work. But I think it's going to be very hard to read. So I'm going to basically put a supplier of optional of what is this class? Path with transport. And I'm going to say async task. So I'm going to create an asynchronous task in the form of a supplier. And what is this supplier going to look like? Basically this. Right. What is the problem here? But return type. Yeah, probably because I shouldn't be doing the if present. Okay, so now this returns something. So this expression here, we're creating a lambda and we're putting it into a variable. So remember that in functional programming, functions are first-class citizens. So we can put functions into variables. So in here, we can simply say async task. And that is very useful because we don't want to put this huge piece of code inside here because it's going to make it really hard to understand. Another way we could do this is instead of having this like that, we could basically create a method. So let's say we put this into a variable, right? So it's an optional path. So I'm going to do this so I can create a method of this. And I'm going to call it, get path with transport. Okay, so now I have this method get path with transport inside this class path application. So now I can use method reference get path. Sorry, not method reference. I could create a supplier like this. Get path with transport. You see? So now it's shorter syntax. That's all I do. Right. And finally, I want to do something with this that is going on in the background. I want to going to say then accept. So then accept is a method that will take something and consume it. So because we don't want to return anything else, we just want to send a notification, we're going to consume the output of this. So if you look at the signature here, now I'm going to get a path with transport optional, right? This is an optional path with transport. And here I can do path with transport optional map. Sorry, if present, and I could do notification service, notify user. Okay, you following me? Right. And for the sake of our test, and because this is going to, if I don't do this, it's not going to show up exactly what I want. I'm going to put this into a variable, but it's really not required for in a real application. And I'm going to do something called join. So what is join do? Join will so this now is going to be executed in a separate thread, right? So we'll have two threads: the main thread where we are ordering the creation of the completable future and all that, and then we have the actual thread where everything is going to be executed. Join is an operation that will join both threads back together, and it will give you the result of the thread. So in this case, join will not give you anything because this operation then accept doesn't return anything. So, but in some, if you are actually expecting a value out of this operation, like if you did, for example, then apply, which returns a value, then in that case, you would do join and you could expect the value and you can wait for that value. I do this because if I end the execution at this point, because this takes 2 seconds, the application will stop running. So I'll show it right away. I'm going to do something else. I'm going to be printing the thread name. Thread name for main function is, and in here I'm going to say thread current thread get name. And in the case of this, I'm going to put here thread name for find path with transport is, and it's going to give me a different thread name. If we're doing things correctly, if I run this now, we'll have two different threads. So let's run this. All right. So everything still works the same, except for if you noticed, the process completed was executed right away. Remember what happened before? Before we had the find paths, then path found, then this, and then process completed. But we want to finish immediately. Like we want to give the user control immediately. So we finish the process at that point, and then these things run on the background. So notice the name of the threads. The main function is running in the main thread, but the find path with transport function, it's running in this different thread. So that is, and we don't really have any. We don't know that we're dealing with threads or anything. We just uh, creating asynchronous tasks, and we're using these higher level abstractions to make our lives easier when we're dealing with asynchronous tasks. Um, and there are many other options, like, for example, if I have a lot of async function, completable function tasks, I can compose them together with this, for example, all of. All of is a function that takes a list of completable futures and combines them all together into a single completable future. That's really cool. Another option that you can have is, instead of having this, for example, you could have then compose, and this function basically will return a completable future. So this is the monad method of completable future. If you have a completable future that needs to operate with something that will in turn return also a completable future, you can merge them together into a single one, and that is something really useful because you don't want to deal with two layers of completable futures at some point. You just want one layer. So you combine them with the then compose method. Uh, like when we had stream of a string, and we flatten the stream, the same happens with completable features. This is a really cool feature. I don't know if there are any questions regarding this. Um, I don't see any questions on the chat, so I'll move on. Um, but yeah, I mean, Completable Future is a very nice abstraction for dealing with asynchronous tasks. There is also because remember we use that the monad pattern. It's used to so that we can use these operations as if they were regular functions. So like this, we're using it as if we're almost using get path with transport and the notify user as if we were not running things in a different thread. I mean, we obviously know this is happening because we have completed the feature and we have some syntax around it, but there's not much syntax. And it's not just about that. It's also the fact that we can deal with the side effects of having something running in the background. For example, uh, we can handle exceptions with this method exceptionally, right? This exceptionally method will receive a throwable function, a throwable, which is an exception, and you can do whatever you want with that to handle it. So that is really powerful as well. Um, oh, the question on the chat right now is exactly what I'm talking. I'm talking about how you handle exceptions. So you could ignore the exceptions because that there's one way of handling the exception. It's just basically ignoring it and saying, okay, I'm fine with the exception being thrown, and that's it. And it might be logged at some point, or you can handle it and with this functionality called exceptionally. And there are many ways to handle handle exceptions. You have exceptionally, and then you have exceptionally async, which is basically it will execute in a different thread. And then you have also exceptionally compose, which is a, a an exception handler that runs in a completable future. So you want to flatten it. So there are a lot of different options there, and the most common way to handle exceptions is just using exceptionally, and you can run your handle your code your error handling here. You could say, for example, error handle exceptions D. Then you just simply create your function. You can do whatever you want with your exceptions. You can say, for example, global if global instance runtime exception, and then you do something and so on. So that is a way you can handle exceptions here. Um, in most ways, in most cases, you don't even handle those exceptions because basically you want them logged, and so you usually just if the exception is happening in a thread, it will blow up until to the top of the application, and it will eventually be logged. So usually that's the way you handle it, but you have other options as well. Um, so there's another question: can we run another async task when handling exceptions in a declarative way? Yeah, you can. That's why you have exceptionally async and exceptionally compose. You can run these asynchronously in a declarative way, and there is also pattern matching. In the latest versions of Java, they're introducing the concept of pattern matching, so that you can use switch expressions to do the handling of these exceptions. But I won't go in great detail about that because I think those are preview features yet. They haven't been released. Um, Fine. So now we're going to move on to a new, and we are going to be um, implementing our own pattern. So this is going to be real fun. Uh, what we are going to do is these are let's imagine these things are REST services, right? When something is a REST service or an HTTP service, there is an HTTP call involved in the middle. And HTTP calls, they usually give you a response, but sometimes that response has errors. It's not straightforward. Sometimes it will give you a success response like a 200, but sometimes you'll get like a 400, a 404, and so on and so on. So I'm going to slightly change my my optional here, my return type here, and I'm going to create a new class. So you'll have to you can do this with me. I'm going to put this here, and I'm going to create a new class. Is it a class or a record? I think I'll start with a class for now. Um, it's going to be called result. It might be better to use it as an interface, really. Hmm. We'll see. Um, so now that we have the interface, let's declare the things that we would like to do with the result. So our result will give us something as part of the result, like the body of the thing that we want to get from the REST API. So I'm going to call it T, like type in Java. We usually use T for these generic types. And because we're implementing our own functional pattern, we want to be able to operate with this result as if it was a regular object. So how do we do that? We implement the functor pattern. So I'm going to be creating what is the helper function for a functor pattern. It's the map operation. So I'm going to be implementing the map operation saying result to say b result b map. And what does map take as a parameter? It takes a function. So I'm going to be sending a function, and the function has two generic parameters. One is the input, and the second one is the output. So the input should be the type of the result, the current type, and the second type is the type of the output, which in this case is going to be the return value, which is b. B is generic as well, so this could be any class. And let's call it mapper function. Right? So this is what we want our result to do. We want to be able to map things with our result. And then we also want to be able to flat map our results. So if we have two calls to different services, we want to flat map them. Right? So I'm going to say b result b. I'm going to say flat map. And this also receives a function. And the type, the input, is the same as the input of the result, as the value of the result. But the difference here is that the output of this function has to be a result of p, right? Because we want a function that will return as a result, and we will flatten it so that we don't end up with two results. We just have one. And we're going to call it again mapper function. And what else? So I want to do something with this in the case there was an issue. I'm going to say, what can I do? For example, I could return the value of the result. No, I'm going to. What can I do here? Let's say we can create a method, and it's going to be if success, something like this. Let me see. I don't like that name. Well, let's go with this one for now. But if success function and it will take uh, a consumer. A consumer is a functional interface that only takes an input and it does something with the input, but it won't do anything. It won't return anything. So this would be void. The an action, right? So this is the action that we will do. And what else? We are going to now we need to figure out what types of results we have. We have the successful result, and then we have the the error result, let's say. So in the case of the successful result, oh, actually, we could do what we could do is also we can add a function that would be like a default value or else, and in here we can say supplier, and this will return a default value, default value supplier. So now we said we had two different types of results. So we'll have the successful result, and then we have the error result. So I'm going to create two classes. I'm going to create one class. Actually, I can do implement interface here, implement interface, and I can say success result, right? And now I can implement all methods. And I'm going to create a second implementation here. I can do again implement interface. I can say error result. And also implement methods. So what should we do with the success result, for example? If we have a map, what we would do here, we have successful result will have also a value. So we'll have a t value, and this can probably be a record. We could say t value, and we can if we want to. So what do we do with the map? What we'll have to do is apply the function, the mapper function. So we can do apply, and we apply it to the value, right? And this will return a v. Sorry, we need to create a new success result. You see, because this now will return a success result, but of value b, because we have applied the function. Now again, with the FlatMap, this is easier because we just apply the function, we send the value, and because this function already returns a result b, we don't have to worry about implementing, returning a success result. So this is fine. Now, if success what we want to do is run the action dot accept with the value that we have, and or else we what we want to do is the default value supplier, run it to get the default value, right? So that's really easy. And now we'll have to implement our error result. So our error result, what should we have here? We could have, for example, this could be also a record. And in this case, we could have a integer status code, and we could also have an message string error message, right? So now what happens when we map an error that is an error? If we have an error, we basically don't do anything. What we'll have to do is create a new error, and we'll basically send this dot status code and this dot error message, and that's it. But we don't really need to do anything because the map function will only run if we don't have an error. The same here. We can do exactly the same here. If success, do nothing. We don't want to do anything in this case. Or else, oh, actually, I did it wrong here. I don't need, because this is a success scenario. In the success scenario, I shouldn't do this. I should do basically value, right? And in the case of error, I should call the supplier default. Okay. So in the case of error, I need to call the supplier, not in the case of um, not in the case of success. Sorry. So now we can use our monad in our application. So I'm going to transform this into a result, and I'm going to map this optional into a result basically. So I'm going to say result new success result. Let's create some helper methods to make it easier. In our result interface, I can say default result e success, and I'm going to say success result, sorry, value, the value, and I'm going to say return new success result value. And I can also add a result and we could call it error and say int status code and string message return new error result. Right, so now we can map this into a So path with transport, going to map it to result. Oh, oh, it should be static. Sorry. Where is the result? It shouldn't be default. It should be static. And I should also add this here. So I can do now success. And I'm going to also say or else I can do result or else result error. And because this represents the fact that this is not here, I'm going to put it as a 404. And I'm going to say the message would be path not found, or path with transport not found, right? So now if I go to path application, I'll remove this. And I'm going to say, remove this as well. Yeah, I'll remove all this. I'm going to say path service, find path to transport. And I'm going to, oh no. I'm going to say get path with transport. I had that helper function there. And I'm going to change this to result because now I have changed this. And now I have the hello, hello, hello. So it seems like we had some technical difficulties. So I'm sharing my screen now. Um, right. Sorry about that, guys. Um, I'm going to share my screen again, and I don't know where actually I drop, but I was implementing the function for handling the scenario of success or else. So I want to run uh, an action in the case I have an error. So I could say, oh, actually, I can say, um, in the case of error, I could say function. Uh, this function, yeah, I could say not a function, sorry, a consumer, and this is going to take. I'm going to create a very quick class in the error. Here in the error result, I'm going to create something very simple, a static record, just record, um, status and message going to be int status string message, and so I'll be putting this in. I'm going to be using this here, status and message error action, right? Yeah, I'm using consumer now. I'm looking at the question saying consumer or runnable. I want to use consumer because I want the action to be able to see the status code and the message and maybe print it or do something with those. If that's I think that's reasonable. So now I have to implement this too. So in here I'm going to say error action accept new status and message status code or message. And in the other implementation, which is the success result, I have to implement the method as well. And in this case, I'm going to apply the success action except with the value. And that's it. So let me see if there are any issues here. Error. Yeah, we're good. Notification. Right. So I'm going to go to the application now. And I'm going to say if success or else. So if success or else, in the case of success, I want to notify the user. In the case of error, I want to run this, and I'm going to say um, error finding path status was um, status a message status and message right. So I'll run this. Let's see what happens. So I was able to find a path, but now if I change the parameters here, and I'll I'll change the type of the so that I don't find one. Now you see we have executed the not successful, the error branch. And yeah, that is pretty awesome. Now I'm going to do one more thing. I want this also to return something, even though it will return a, let's say, it's going to be a result with nobody. Um, we could actually we could have this return something like a string and say return um, result success and user successfully notified. Right. So now, if I do that, I will need to do a flat map, right? Because these will return also a result. So I would say path with transport, and this is going to be notification service, notify user, but with transport. And now, in this case, the consumer is just an S. So I could say, so S. And in this case, we'll still have the error message. So now you see, because the first step sent an error, this one was not executed, and that's what we expected. We have combined the side effects into a single layer. Now, if let's say this is successful again, bus, now we run this, and we'll see that this is working now. Excellent. So what else? We should one other thing that we can try is that this fails. We could say error here and notification failed. Let's just say it's a 500 error. So if I run this now, we should see this error, the 500, not the other one. So you see, error finding 500. So we have chained these operations with our new created monad. So how cool is that? Huh? Um, that is all we have for today, guys. So I don't know if there are any questions about this new monad that we have created. I don't know if this was interesting. I'm looking forward to hear from you. You can always reach out to me, and don't forget that next Thursday we'll have our last session where we're going to be using everything we've learned uh, in our next session to do some coding together. So I really hope to see you there. It's going to be super interesting, and I've been having so much fun doing all these classes, all these sessions with you guys. So thank you everyone for joining. And yeah, I see that there are no questions, so I hope everything was clear. And as always, I want to thank you a lot for watching. Um, for all of you that have watched till the end, great job. And we'll see you next session. Bye.